Adding vector components with trig. There are two ways to find a resultant vector when adding vector components. The first is to draw the vectors by hand and measure the resultant. The second way, which is what this video will cover, uses trig functions like sine, cosine, and tangent to calculate the resultant. You're welcome to use whichever method you're comfortable with. Some find the trig method faster, though it does require more math. For drawing vectors by hand, please watch the Adding Vector Components by Hand video. To use trig, continue watching this video. Vector A is 8 newtons in the vertical direction, and vector B is 6 newtons in the horizontal direction. Find A plus B. Vectors A and B represent the vertical and horizontal components of some vector which we're trying to find. Since vectors care about direction, the signs of these vectors matter. In this case, vector A is positive 8 newtons in the vertical direction, meaning it is up, and vector B is positive 6 newtons in the horizontal direction, meaning it is to the right. In order to find the resultant, the vector sum of A and B, we need to add A and B using the tip-to-tail method of vector addition. To find the resultant using trig, we'll sketch the vectors, then find the resultant in direction. Vector A is 8 newtons up, and vector B is 6 newtons to the right. The resultant starts where the first vector began and ends where the second one ends. You can see what we've made is a right triangle. The resultant is the hypotenuse, meaning I can find its length using the Pythagorean theorem. The square root of 100 is 10, so my resultant is 10 newtons long. I'll measure the angle from the tail of the resultant. I can use tangent to find this angle theta. Tan theta equals opposite, which in this case is 6 newtons, divided by the adjacent, which in this case is 8 newtons. Using arctangent, I can find that theta equals 36.9 degrees. Since angles could be measured in any quadrant, we usually measure them as counterclockwise from the positive x-axis for consistency. This means we should actually report this angle here, which is 90 minus theta. 90 minus 36.9 gives me 53.1 degrees, and that's the angle of my resultant. For the second example, vector A is negative 9 newtons in the horizontal direction, so left, and vector B is 5 newtons in the vertical direction, positive, so up. After sketching the resultant, again, I have a right triangle where the hypotenuse is the resultant. I can again use Pythagorean theorem to find out what the resultant is. May need to use a calculator here to find out what the square root of 106 is. It's about 10.3. That is the resultant, the length of the resultant. Use tangent to find the angle theta. Again, tangent is opposite over adjacent. An arctangent can help me find the angle. Which is about 29 degrees. However, what I'm really looking for is the angle from the positive x-axis. which would be this. And here you can see that would be 180 minus theta, or 180 minus 29, giving me 151 degrees.